Hello, Shahab Ahmad here again. The target for today is to solve every past paper MCQs on chemical equilibrium, but we will do that different than most of the people, I would say. How it will be different, I don't know, but the thing is that first of all, I'll discuss the topic that is related to the MCQs I'm gonna discuss. So here, the first topic, the chemical equilibrium. Related to the chemical reactions that occur in both directions, forward as well as backward. So this is the specialty of such reactions, and for these reactions we will discuss chemical equilibrium. First of all, I must say that these reactions happen in a closed vessel. So the first thing is, in such reactions, reactants combine to form products. Like A plus B combine to form C plus D. Suppose I would say, as is present everywhere in the books, etc. So A plus B forms product. This is forward reaction. But what happens in the backward is these products combine to form the reactants back. So it is represented by such arrows, and I would write backward. So such reactions must occur in a closed vessel. So the first necessity for such reaction is closed vessel. Second thing I must mention is that at the state of equilibrium, rate of forward reaction equals rate of backward reaction. So these are the two things I should have mentioned before going to MCQs. Now I'll write these points in bullets to the side, and then I'll write MCQs over here and give you time to solve them. If you are not able to do that, I will solve it for you. So bear it with me. So here are the questions on the concept discussed. First one, the first question appeared in 2006 paper. It is saying that for a reversible reaction to reach an equilibrium, the reaction is said to be carried out in. So as discussed earlier, glass vessel? No. Iron vessel? Not necessarily. Open vessel? No. Closed vessel? Yes, as discussed. The reaction should occur in a closed container. So easy peasy. Now the second question. This question was repeated in 2009 paper and then reappeared in 2020 paper. The same question. When does a chemical reaction attain equilibrium? So as said earlier, at equilibrium, rate of forward reaction equals to rate of backward reaction. So the easy answer is the first one. So the real answer is the first one. Rate of forward reaction is equal to rate of backward reaction. But we will look at other options too. Reaction takes place. Yes, reaction must take place. But that is not our answer. 50% of the reaction is complete. No. It is not necessary. Concentration of products and reactants are equal. No, it's not necessary. So the correct answer, as you have marked it correctly, is option number A. So now we will go to another topic, discuss the topic, and then discuss MCQs on that topic. So here now, we'll discuss first of all the concepts, and then the MCQs will come after that. So effects of concentration, pressure, volume, and temperature on equilibrium position. What will happen if you increase concentration? It pushes the reaction in its opposite direction. What does it mean? If you increase the concentration of reactants, the reaction will go in forward direction. Okay, opposite to the reactants, the reaction goes in that direction. If you increase the temperature, the concentration of the products, the reaction will come in backward direction. So pressure effects happens in gaseous state mostly. We'll discuss it also in the equilibrium between solid and liquid also, but here in gaseous state. Case 1, if delta N is equal to 0, what does this mean? That the number of moles in the reactant side is equal to number of moles on the product side. So if the number of moles on the reactant and product sides are equal, then there will be no effect of increase in pressure in that case. Then in second case, if the number of moles on the reactant and product side are not equal, delta N not equal to 0, in that case what happens? Increase in pressure will push the reaction in the direction where there is lower N. What does this mean? If you increase the pressure on the system in which the reaction is happening, so the reaction will go in that direction where the number of moles are lower. Means in the reactant and product side, we will look for the number of moles. If the number of moles on the reactant sides are low, the reaction will, on increasing the pressure, the reaction will go in backward direction. If the number of moles on the product side are lower, what will happen if you increase the pressure? The reaction will go in forward direction. So that is the whole concept of that. Temperature. What is the effect of temperature? Increase in temperature favors endothermic reaction. So you have the reaction that is reversible. In one side it is endothermic, on the other side, toward the other side it is exothermic. So if you increase the temperature, it will favor the side that is endothermic. So this is the whole concept building. Now we will come toward the MCQs and we will solve our first MCQs on this concept and the third MCQs of the chapter. Consider the reaction in which hydrogen and nitrogen combine to form ammonia. Okay, all of the following will lead in this reaction to the production of more NH3 except. So what are they asking is that these are the conditions given. All of these conditions increase the production of ammonia except one. Okay, first, a decrease in volume of the container. So if you decrease the volume of container, you increase the pressure of the reaction mixture. So increasing the pressure will have effect in which case? If the number of moles are not equal, and it will favor in the direction where the number of moles are lower. We have already discussed that concept. So we will look for the number of moles on both sides. Decrease in volume will favor the side that has lower number of moles. So here the number of moles 3 plus 1 4, and here the number of moles 2. So decrease in volume will favor production of ammonia. So this is not our choice because it is favoring the production of ammonia. Second, removal of ammonia. So removal of ammonia means you are decreasing the concentration. So increase in concentration favors the reaction in its opposite direction. Decrease in concentration of substance favor reaction in its direction. So if you remove ammonia, the reaction will go forward. So this too is not our choice. Increase in pressure by addition of H2. So if you increase the pressure by addition of H2, what will happen? The reaction will go in the direction where there are lower number of moles. So it will also favor the production of ammonia. So none of these three is our option. So we could mark none easily. So this was this MCQs. We will go to other MCQs now. First of all, you should look at the question and mark your answer. This question was posed in 2019. The question says, consider the reaction in which hydrogen and nitrogen combine to form ammonia and release some heat. Means this reaction is exothermic. The production of ammonia will be maximum at. So the question is, temperature and pressure are given. As mentioned earlier, this reaction will go forward if the pressure is increased, because the number of moles in the product side are lower than the number of moles in reactant side. So increasing pressure will favor production of ammonia. First, we have marked high pressure. So temperature, what will happen for temperature? So as we know that increase in temperature favors endothermic reaction. So if you increase the temperature, this reaction is forwardly exothermic, it is endothermic in backward direction. So if you increase temperature, the reaction will happen in backward direction. So we must not do that. We must decrease the pressure. So we must decrease the temperature. So low temperature. So now we should find our answer in these options. High temperature, no. High temperature, no. Low temperature, yes. Low pressure, no. Low temperature and high pressure, yes. This one is our option. Look at the question. First of all, you must try to solve it by yourself, and I'll give it a try. This question was posed in 2008 paper. The question is saying, consider the reaction between SO2 and O2 forming SO3 plus releasing some heat, means exothermic reaction. So the yield of the reaction of SO3 will be maximum 8. So the option is between temperature and pressure. We have to opt between them. So first of all, for the pressure term, look at the reaction. We know that increasing pressure favors the side which has lower number of moles. So here the number of moles equals 3 on reactant side, and product side number of moles are 2. So at high pressure the yield will be maximum. High pressure will favor the product side. Okay, now for temperature, we know that increasing temperature favors exothermic reaction. Endothermic reaction. So here the exothermic side is on the back side, because in the forward side it is exo. So on the backward side it will be endo. So increase in temperature will favor production of the reactants. So we do not want that. So we will decrease temperature. So lower temperature means high yield. So we will find this answer: high pressure, and low temperature, So option D is the correct option. And I hope you have marked the correct option. So again, a question on the concepts we discussed. The question is saying that hydrogen and iodine are reacting to form hydrogen iodide. This reaction is affected by which of these parameters affect this reaction? As we discussed, if the number of moles on both sides are equal, then there will be no effect of pressure on a gaseous reaction. So here number of moles 1, 1, 2, and here 2. So the number of moles on reactant and product side are equal. So no effect of pressure or volume on this reaction. And this reaction is occurring in the gaseous state, so no effect of pH also. So it is affected by what? Only temperature, because pressure and volume or pH are not affecting this reaction. So you have marked the correct answer. I know that. So a very good question was posed in the paper of 2010. You must give it a try. Reactants formation in an endothermic reaction would be favored by. What is it saying? That this reaction is endo, in forward direction. So its reactants formation means the formation of reactants would be favored by, as we discussed earlier, that increase in temperature favors endothermic reaction. So this reaction is endothermic in forward direction. So in exothermic will be exothermic in backward direction. This reaction is endo in forward direction, so will be favored by high temperature. So obviously will be favored by low temperature in backward direction. Again, as said earlier, increase in temperature favors endothermic reaction. So this reaction will go toward the product if we increase temperature. So if we decrease temperature of this reaction, it will go toward reactant side. So the reactants formation will be favored by what? By decrease in temperature, because increase in temperature will favor endothermic reaction, and this reaction is endothermic in forward direction, and we want it to go in backward direction. For that we have to decrease the temperature. So this was the answer. The question was repeated. First it appeared in 2010 paper, and then it got repeated in 2012. The question says, for an exothermic reaction, 2NO converts into N2NO2. The rate of forward reaction is favored by. So this reaction is exothermic in the forward direction and endothermic in backward direction. So if we increase the temperature, as we have written it over here, increase in temperature favors endothermic. So increase in temperature favors backward reaction. So decrease in temperature will favor forward direction reaction. So option B is correct, because decrease in temperature favors exothermic reaction. So you must look at this question and solve it by yourself, because we have now seen so many questions like this. So the question is saying that for an exothermic reaction, PCl3 plus Cl2 forms PCl5. An increase in yield will be favored by, means how we can increase the yield of PCl5 means the forward reaction. So this reaction is exothermic, and we know that increasing temperature favors endothermic reaction. So we must decrease the temperature to favor exothermic reaction. So that was quite simple. The option B is correct, decrease in temperature. So first of all, we have to discuss a bit of concept, which I said here I discussed in pressure case, but not elaborately. Here again I'll give a hint to it. Effect of pressure on solid and liquid at equilibrium. So if solid and liquid are at equilibrium with each other, what will be the effect of increasing pressure in that case? Increasing pressure favors more dense side. So if I increase the pressure when solid and liquid are at equilibrium, what will happen is the equilibrium will shift to the more dense side. So here the question is posed: ice and water are at equilibrium with each other. Ice, like water, H2O, solid, is in equilibrium with ice and water. So water means liquid. They are at equilibrium with each other. By increasing pressure, the equilibrium will shift. So if I increase the pressure here in this case, I know and we know that solid ice is less denser than liquid ice. So increase in pressure will favor formation of liquid ice, because this is 9% more denser than solid ice, because of, as we know, hexagonal formation of those crystal. What will happen is the reaction will go in forward direction, because increase in pressure favors the more dense side, and here liquid water is more denser than the solid water. So the reaction will go in forward direction. So now again we will discuss the topic, and then we'll go to its MCQs. So the topic is Kc, which is the ratio of the concentration of the products to the reactants. So here I have taken an example of reactants and then products. So products goes up and reactants down to the power of the respective coefficient. So the coefficient of the products goes in its power and the coefficient of reactants in its power. And here the unit of Kc changes with respect to the number of moles of reactants in products. If the number of moles of reactants in products are equal, the Kc will be dimensionless. Okay, then what is the use of Kc? What is its significance? Its significance is that it tells us about the extent of a reaction. So larger Kc means more products are formed. Smaller Kc means this reaction doesn't happen that much well. This means that this reaction's yield is very low, means more reactants are there in the chamber. Then Kc dependency. Kc is independent of catalyst concentration, initial concentration I mean, and pressure or volume. It depends only on temperature. So for a specific temperature, we will have a specific value of Kc. Then Kp and Kc's relation. Kp equals Kc RT power delta N. Delta N means the difference between number of moles of the product to the reactants. So now we will discuss MCQs on these topics. So now we have to solve the first question on this concept. The question appeared in 2012 paper. It was asking select the correct equilibrium constant expression Kc for the following reversible reaction. So this was the reaction given, and we were to write or select equilibrium constant Kc expression for this reaction. So we can write it. It's very easy. We will put the concentration of the products in the upper side, that is cesium plus 3 and iron plus 3, the products in the numerator to their power. So coefficients are 1 1, so we do not write 1, and here in the denominator cesium plus 4 and iron plus 2. So this is our Kc expression for the reaction. So in 2010 paper we were asked for the units of Kc for the reaction. So as mentioned earlier, that the unit of Kc could be found from the coefficients. We have to put the units of molarity in the products and in the reactants. Okay, moles per dm cube in the products and then down in the reactants too. Power to the coefficients. So here, if, as I said earlier, if the coefficients are equal, so if the coefficients on both sides are equal, then we will have a dimensionless Kc. So here we will find out if the number of moles on both sides are equal or not. Here number of mole of carbon side is 1 water molecule, 1 carbon dioxide and 1 H2. So here total number of moles 2, here 2. So both of them cancel each other out. So we will have a dimensionless Kc. You must look at this question first. It says that if the Kc of a certain reaction is large, it indicates that at equilibrium, reactant concentration will be high, product concentration will be low, the product's concentration will be high, or both are equal. So we have mentioned it already over here. If Kc is large, more products are formed. This is understood. So if Kc value is very high, means the product concentration will be high. So this is our answer, and it appeared with different wording in different papers. In 2007 it appeared, I think, this such wording, and in 2019 with another wording. If Kc value is very low, what does this mean? And in 2019 again. In 2008 the the example of ozone and oxygen was given. So the concept remains the same. If Kc is larger means more products. If Kc is small means more reactants are there. So the question is, the Kc for a reaction in which N2NO2 combines to form 2NO is 4 multiplied 10 to the power minus 4 at 2000 Kelvin. So at a certain temperature, the value of Kc is this. Then, in the presence of a catalyst, the equilibrium is attained 10 times faster. So if then a catalyst was introduced into the reaction chamber, and the equilibrium attained was 10 times faster than without the introduction of the catalyst. So the Kc in the presence of a catalyst at 2000 Kelvin is, so again temperature is not changed, and the Kc, we are asked for would there be any change in the value of Kc. So we have already discussed this, that Kc is independent of catalyst. So catalyst does not change the value of Kc. So our value will remain the same as it was previously, 4 multiplied 10 to the power minus 4, because temperature has not been changed. So this is our value. Now we will introduce another concept, that is the concept of solubility product, Ksp. So we use this for sparingly soluble salts, as you know that. Suppose a salt of kind A2B, it dissociates into two cations of A in one anion of B. The charges are -2 and +1. So suppose the solubility of this salt is S mole per dm cube. So what will be the solubility of the cation? 2 times of S. And what will be solubility of anion? Because it is mole ratio of both of them are equal, 1:1. So here we will have S moles per dm cube of B. So the Ksp is written as as we have seen in the case of Kc, but here we have shifted the denominator into this side and converted into Ksp. So again, both the cation and anion to their respective coefficients are in the power to their concentration. So here the concentration of A to its power, okay, concentration of B to its power. Again, I'm putting the concentration of both, that is the concentration of A is 2 times solubility of the salt, and the concentration of B is 1 time the solubility. So I'll put both the values of both. From here onward I can do the calculations that as 2 to the power 2 becomes 4, and 2 to the power S becomes 2 S power 2, and multiply with S. So S multiplied S squares become S cubed, and 4 comes in its place. So now if I am given with the solubility, I can find the solubility product very easily. So look at this question. It appeared both in 2017 and 2019 paper. It is saying that the solubility product Ksp of Ag2Cr2O7 at 25 degrees C was 2 multiplied 10 to the power minus 5 molar. The value of Ksp is, so we have to find the Ksp as we discussed over here. So this salt, what is this? What is the kind of this salt? This salt is of that kind as we discussed over there. It is A2B. So here Ag2Cr2O7 dissociates into 2 ions of Ag plus 1 ion of Cr2O7 minus 2. So to find the solubility product Ksp of this question, of such a question, we have to use that formula, 4 times the solubility power 3. So we have given the solubility of the salt. We have to plug the value in over here. 4 multiply the solubility is 2 multiplied 10 to power minus 5 power 3. So what I get is 3 2 power 3 becomes 4 in its own place. It becomes 8 multiply 3 into 5 15 10 to power minus 15. So if I multiply 8 with 4, I'll get 32 multiply 10 to power minus 15, or 3.2 multiply 10 to power minus 14. Is this present in our answers? Yes. Option number A, 3.2 multiplied 10 to the power minus 14. So we must remember the formula for finding the KSP and how we derived it. You must also remember that. If you know the process, you can solve it over there. But the question posed in the paper will be quite easy, as this again one more question was posed in this paper, that what does larger KSP means? Larger KSP means more solubility. Okay, more ions are present. So if more ions are present, means the KSP value is large. First of all, we will discuss the concept of the buffer, and then we will solve some MCQs with it. So buffer is a solution that resists change in its pH. If you add a smaller amount of strong acid or a base to it, it will not change its pH. So there are two kinds of buffers: acidic buffer, that is made up of a weak acid and salt of that acid with a strong base. So weak acid, suppose acetic acid in this case. I have taken the example of it. And example of salt, this acid salt is sodium acetate. And also basic buffer, ammonium hydroxide and ammonium chloride. So a weak base, ammonium hydroxide, and its salt, ammonium chloride. So in this case, the sodium comes from NaOH, and here in this case, chlorine comes from HCl with strong base, strong acid, sorry, and here a strong base. So how can we find the pH of a buffer? That is through pH is equal to, this is a formula, Henderson-Hasselbalch equation. pH is equal to pKa plus log of concentration of salt into acid. The salt that is over here, the salt over here, and the acid over here. So if I take the concentration of both and then take the log of it, I must add it with the value of pKa, and I'll get the pH of the buffer. So, and then I have to talk about the buffer capacity. The capacity of the buffer is maximum when the pH of a buffer is equal to its pKa. And how would that be equal? That be equal when I get log 1, because log 1 equal to 0. If I get 0 from this term, then I can get pH is equal to pKa. How will I get log 1? I'll get log 1 if I take the concentration of salt equal to the acid. If I take both of them equal, then I can get pH is equal to pKa and a maximum capacity buffer. So now we have to solve the question with the help of concepts we learn. Which one of the following cannot be classified as buffer? So for a buffer, we must have a weak acid and its salt with a strong base. So we must find a strong acid. That will not be a buffer. So first of all, H3PO4, a weak acid and its salt, it's okay. Here, HCl4, one of the strongest acids. So this is a strong acid. This could not be classified as a buffer. We should also look for other options too. So yes, a weak acid and its salt, it's okay. A weak base and its salt, it's also okay. So we have reached the last concept of for today's discussion and today's questions. It is common ion effect. It is what is common ion effect? It is the effect of decreasing the solubility of a compound by the presence of another compound that has a common ion to the compound that was already present in the solution. I've already studied and learned that higher concentration of a substance pushes the equilibrium in its opposite direction. Suppose the concentration of a reactant is high, so it will push the equilibrium in its opposite direction uh, toward the product. And if the concentration of the product is high, it will push the reaction in backward direction. So here, the same phenomenon, the same concept applies over here. Here, a common ion, suppose this salt was already present, AB salt was already present in the solution. I added another salt that was AD. So what happened was the concentration of A increased. So it will automatically push uh, the equilibrium in backward direction, because increase in A will push as the increase in concentration pushes the equilibrium in its opposite direction. So we will have the formation of either AD or AB. That depends upon Fajan rules. Which one is more soluble? The salt, the salt that is more ionic will be more soluble. So that salt which is more ionic will remain in the solution, and that salt that is more covalent will precipitate down. So another question mentioned was NH4OH was already present in the solution. Consider the above ionization. NH4Cl is added to the system. The equilibrium will shift too. So if this base NH4OH, we discussed it in the section of buffer, that this is a weak base. So weak base means low ionization. So this was present in ionized form. What happens if I add a salt? This salt is more ionizable. We will have maximum ions of this salt. So this will hamper the ionization of this base. Why? Because same ion NH4 here and NH4 plus here, they are present, they will be present on the same side of the equation. So increase in concentration of ammonium ion will push the reaction in backward direction. But for which one? For this one. It will shift the equilibrium toward left side. So the reaction will come in backward direction. So another question was asked, aqueous solution of KBr was added to the aqueous solution of MgBr2 due to common ion Br minus. Ions equilibrium is disturbed. To attain it, okay, what will happen to attain the equilibrium? Aqueous solution of KBr was already present, but because of addition of magnesium bromide, the equilibrium was disturbed. What will happen? Either magnesium bromide will precipitate or KBr will precipitate. So here we must know the Fajan's rule, or we would not be able to solve this problem. This is +2 ion and this is +1 ion. So +2 ion has more effect of, it can polarize the Br more. So we will have more covalent character over here. So more ionic means more soluble. So this will not happen. This will remain in soluble form. What will happen? We will have the happening of this magnesium will uh, combine with the Br to form magnesium bromide again. So our option B is correct. So thank you for today. Thank you for your time. Thank you for bearing it with me. You can give me your opinion in the comments below. How was it? How you felt about it? Have you gone through the whole of this series for today? If yes, then please let me know how did you feel about it. Thank you.